Hello students, in this part we will be talking about the discovery of proton as well as the Rutherford model of an atom. So let's start with this. So this is how the experiment something look like. This is almost as same as that of the cathode ray experiment, but there are few key differences that we should know. The very first one is that if you look in this, the fluorescent screen is now behind the cathode. The cathode is now perforated, and the important thing is in this experiment the rays are, or your particles are traveling from anode to cathode. So this will tell us that the anode rays are positively charged particles, but we'll look into it, are they positively charged, right or wrong. So let's start with this. Another few things that you should note, that the voltage is same, only the placement of fluorescent screen and perforated cathode are used. So let's see a few observations. The very first one is that in this experiment the pressure of the gas which we are using is now 10 to the power minus 1 mmHg, that is 0.1 atmospheric pressure we are using. In the previous one, if you remember, it was 0.001 atmosphere. So why is this? Because so that your charged particles, because they are a bit heavier, we'll see why they are heavier. These are heavier particles, that is why they need a bit more pressure so that they can travel. Let's see the next observation. It was seen that anode rays were colored on changing every gas. If you take hydrogen, the color of the gas will be different. If you take neon, the color will be different. Similarly, krypton, argon, xenon, all of these gases will be having different colors. Let's see the next observation. It is that behind the cathode, our screen is illuminated. Let's see the next one. The particles were found to be positively charged because they were moving from anode to cathode. Also, if we use the same experiment, if we keep the anode rays in the another electric field, what will happen? Look over here. So anode rays are moving something like this. Let's say this is negatively charged, this is positively charged, and they will be deflected on this side. From this we can understand that anode rays are made up of positively charged particles. The next observation was that the anode rays were made up of gaseous charged cations. They are made up of charged cations, not protons. See, let's say we are taking helium, which has 2 proton, 2 neutron and 2 electron. On taking out 1 electron from the helium, we will be having helium positive. Now this helium positive has 2 proton, 2 neutron and 1 electron. Is it made up of protons? No, it is made up of He positive, which is a gaseous cation. This is a very big misconception among students, is that if cathode rays are made up of electron, your anode rays must be made up of proton, but it is not the case. Only in the case of hydrogen, which has 1 proton and 1 electron, if I take out 1 electron from it, we will be having H positive, which is only made up of 1 proton. So H positive or your hydrogen ions are nothing but they are only protons. Let's see the next observation. The gaseous charged particles or your anode rays are deflected in both magnetic field as well as electric field. In the previous class, I also told you that both charged particles are deflected in both magnetic field and electric field. the next observation was that on changing the gas, your charge to mass ratio was also changing. Look over an example, He positive. The charge on the gas is 1 while its mass is 4 units, 2 protons and 2 neutrons. In the case of neon positive, the E by M ratio, it is equals to 1. Obviously the charge is 1 and the mass is 20. There are 10 protons and 10 neutrons. So watch yourself. On changing your gas, your charge to mass ratio is changing. In case of helium, it is 1 by 4, but in the case of neon, it is 1 by 20. Anode rays were found to be made up of gases. This is the overall conclusion, that they are made up of the gaseous cations, and on changing the gas, the charge to mass ratio will change. Now let's see some conclusions about the anode ray experiment.